Hi, I am Syed on Maths Online. In the previous video, we studied about the Laplace transform of elementary functions, and then we have discussed about the Laplace transform of the constant, Laplace transform of a to b, a by s, Laplace transform of e power of at to be 1 by s minus of a. Then we have discussed about Laplace transform of cos hat is s by s square minus of a square, and sin hat will be a by s square minus of a square. Laplace transform of cos at will be s by s square plus a square, and Laplace transform of sin at will be a by a square plus a square. So if you want to know the details about these transform, you can watch my previous two videos. In today's session, I'll be taking up with the Laplace transform of t power of n. So we'll try to find out the Laplace transform of t power of n. So to find out the Laplace transform of t power of n, so once again I'll be using the basic formula for Laplace transform. The Laplace transform of f of t will be equals to, we know it is nothing but integral of 0 to infinity. It is e power of minus of st f of t into dt. That's the basic formula for Laplace transform. So now here your value of f of t is nothing but t power of n. So f of t value is t power of n. So to solve this problem, what I'll try to do is, I'll try to take this particular value of st, this value of st that you have, I'll replace this st by some other value. So let me put the value of st to be equals to, say, x. If I take st to be equals to x, then the value of t can be written as t will be equals to x, cross multiply that s, it becomes x divided by s. So I have to replace this back in the given integral. I have to get the value of dt. So let us try to differentiate this one. So if I try to differentiate, derivative of t will be dt is equals to derivative of x will be dx divided by s is a constant as it is. And also if you try to observe, as the value of t is varying from 0 to infinity, those are the limit values over here. T value over here is 0 to infinity. In the same way, now if I try to convert this t in terms of x, so x value will be ranging from, so here if I try to observe in this case, so if the value of t is 0, what will be the value of x? X value will be 0, right? X value will be equals to 0. 2, if the value of t is infinity, then the value of x will also be infinity. So x is also ranging from 0 to infinity. So if I try to rewrite the value of L of f of t, so I can rewrite that value to be equals to Laplace transform of f of t value, I have taken it as t power of n is equals to, so apply the integral values there. We have integral x value is ranging from 0 to infinity. It is e power of minus of st. But what is the value of st I have chosen? The value of st I have chosen it as x. So replace st to be equals to x. So e power of minus of x into f of t. F of t value I have taken it as t power of n into dt. So what is the value of dt? So just now I have calculated the value of dt over here. The value of dt is dx by s. So if I write down, it becomes dx by s. So further, if I try to take that s outside, so it becomes 1 by s. It is integral of 0 to infinity. You have e power of minus of x f of t, but we know the value of f of t is how much? F of t value is t power of n. But what is the value of t over here? The value of t is x by s. So it should be x by s whole power of how much? Whole power of n. So therefore, in place of this f of t, I can write the value as x by s to the power of n into you have dt value. So dt value over here, dt value is dx by s. So dx by s. So if you try to rewrite this integral value, we will be getting integral of 0 to infinity. It is e power of minus of x. So this will be x power of n divided by s power of n. It is dx by s. So in the denominator you are having s power values. So I can rewrite this as integral of 0 to infinity e power of minus of x power of n divided by s power of, because the bases are the same, you can just add the powers. It becomes n plus 1 into this dx. However, that s power of n plus 1, you can take that outside. You will be getting 1 by s power of n plus 1. It is integral of 0 to infinity. It is e power of minus of x power of n into dx. But this particular value is nothing but the gamma function, which is nothing but 1 by s power of n plus 1. So this complete integral value represents the gamma function. So it can be written in the form of gamma of n plus 1. So integral 0 to infinity e power of minus of x power of n dx is nothing but gamma of n plus 1 value. So therefore, you have got the value of Laplace transform of t power of n. So this will be valid when the value of n is a constant. When n is a constant, you can use this particular result. So Laplace transform of t power of n, we have got this value to be equals to 1 by s power of n plus 1 into gamma of n plus 1. Suppose if the value of n is a positive integer, in that case what will be the value of Laplace transform of t power of n? So we'll take that result also. So the next result is to find out the Laplace transform of t power of n when the value of n is a positive integer. If n is a positive integer, in that case what will be Laplace transform of t power of n? So we know the formula for Laplace transform of f of t. Laplace transform of f of t will be equals to integral 0 to infinity e power of minus st f of t into dt. So I'll try to replace the value of f of t to be equals to t power of n. So Laplace transform of t power of n will be equals to integral of 0 to infinity e power of minus of st, and f of t value is t power of n times of dt. So now we need to integrate this integral value. So to integrate it, we will try to integrate this by parts. So integrating by parts. Integrating by parts. So if you want to integrate by parts, then we know the formula for that is integral of u into, it is v dash, u into v dash into whatever the function it is, whether it is in terms of t or whether it is in terms of, here if I am taking in terms of t. So the general formula that you have is, it is u into v minus integral of, it is v into du. This is the basic formula that you have. Alright, so let us try to use this formula over here. So if you try to compare the values over here, now we use what is called as the Eilert principle or Hamlet principle. I hope you might have already learned this one. So just for a revision purpose, I am just rewriting this one. So I represents the inverse function, L represents the logarithmic function, A represents the algebraic function, and T represents the trigonometric function. It represents the trigonometric function, and E represents the exponential function. Exponential function. So choosing the value of u should be in this particular order. Whichever comes first has to be taken the value as u. So if you try to observe here, exponential function is at the end. So e power of minus of st, exponential function, and you have t power of n. So t power of n represents the algebraic function, that is t power of n. So which function is occurring from the top as first? T power of n is occurring first, therefore we will be choosing this value to be equals to u. So t power of n will choose it as u. This function will choose it as v dash. So once if you choose these two values over here, so your value of u will be nothing but t power of n, and your value of v dash will be equals to, it is e power of minus of st. So we'll try to differentiate the first function du, derivative of u is du, and differentiation of t power of n will be n into t power of n minus of 1, whereas this v dash which is there, we'll try to integrate it. So we have to integrate this, also we have to integrate it. So if you are trying to integrate, so you are integrating with respect to some particular variable. So I'll write down that variable here. So because you are integrating with respect to t, I'll write it as dt. So e power of minus st into dt. So v dash integral will be v, which is equals to, and integration of e power of minus of st will be nothing but e power of minus of st divided by the coefficient of t is minus s. So we'll be getting e power of minus of st divided by minus of s. So that will be the integral of e power of minus st. So now if you want to use this formula, so we will be getting the value to be equals to this Laplace transform of t power of n as it is, which will be equals to, so I have to plug in over here in this particular integral. So this integral value will now be equals to uv. So that integral value will be nothing but uv minus integral of v into du. So if I try to use that one over here, I will be getting u into v. So u value over here is t power of n. So this value u is t power of n into v. V value is this. It is e power of minus of st divided by minus of s. So because you are having integral over here, integral is running from 0 to infinity. So therefore I have to write down the integral value to be equals to 0 to infinity. So the value of t is running from 0 to infinity. So I have written uv, right? uv, then you have minus integral of v du. So let us write down that value. V value minus of, it is integral of v. What is the value of v? It is e power of minus of st divided by minus of s into du. So du value is over here. Du value is n t power of n minus of 1, whereas the limit values for t are running from 0 to infinity. Right, I have just rewritten this value. Or further, if you try to write down over here the upper limit value, it is t value will be infinity, upper limit value is infinity, e power of minus infinity will be 0. So if you apply the limit, upper limit value completely will become equals to 0. Minus of the lower limit value for t will be 0. So 0 into anything will be equals to 0 itself. So the whole of this first term becomes equals to 0. Then coming to the next term, minus of minus will become plus. If you want, you can take the value of n outside divided by s also outside. Then you have integral to be equals to 0 to infinity. You are left out with e power of minus of st. It is t power of n minus of 1. Here you have dt. So here also you have dt. Further, if you try to rewrite this expression, 0 you can ignore, so you will be left out with n by s. So this integral, if you try to compare this integral over here, it is integral 0 to infinity e power of minus st t power of n minus of 1 into dt. So this integral, if you try to compare with this particular integral over here, so if you have t power of n, so you are writing t power of n. But here you are having t power of n minus of 1. So therefore you can write this as Laplace transform of t power of n minus of 1. If t power of n is there, you are writing Laplace transform of t power of n in the earlier step. Here, because you are having t power of n minus of 1, therefore you are writing Laplace transform of t power of n minus of 1. So therefore we have got Laplace transform of t power of n to be equals to n by s Laplace transform of t power of n minus of 1. Similarly, if I want to find out this particular expression, and what has to be done? So let me take this as some equation number, maybe equation number 1. So now if I want to find out this particular value, I will write Laplace transform of t power of n minus of 1. I want to find out this value. So therefore, once again, if you try to see over here, if n is there, you are writing n value. So here if n minus 1 is there, then what has to be written? You have to write n minus of 1 divided by s into the same step what I have written earlier, Laplace transform of. Because you are having n in this case, the power will become n minus of 1. So the power is reduced by 1. So here if n minus 1 is there, if I am trying to compare, you have to reduce the power by 1. Therefore you will be getting t power of n minus of 2. Alright. Similarly, if you want to find out the Laplace transform of t power of n minus of 2. So following the same logic, n minus 2 is there, you will be writing the same value, n minus of 2 divided by s. Then Laplace transform of, you have to reduce the power. So if you reduce the power, n minus of 2 will become n minus of 3. Alright. So in this way you can just go on writing, right, and so on. You can go on writing this expression. But if I just go on repeating this process, what will be the final expression? So the final expression, you can see that the power of t is going on decreasing. If it goes on decreasing, it has to reduce to some value, that is t power of 3, t power of 2, t power of 1. Right? It has to reduce in that form. So suppose if I say it reduces in this form and becomes equals to 2, in that case what will be this particular value? Laplace transform of t square. So if it is Laplace transform of t square, if I follow the same rule what I have written over here, the same rule, so power n minus 2 is there, the same value you will be getting over here. So n minus 2, you are getting n minus 2. So if 2 is there, you will be getting 2 itself. So 2 by s, we'll be getting Laplace transform of, here the power is reduced by 1, so therefore if I reduce the power by 1, so t power of how much? We'll be getting 1, so because 2 is there over here, so 2 minus 1 will become 1, so I'll be getting t power of 1. So further, in the same way, if I want to find out the Laplace transform of t power of 1, following the same logic, the power has to be the same. 1 is there, we'll be getting 1 by s, we'll be getting Laplace transform of t power. So the power has to be reduced, 1. So 1 minus 1 will be getting, 1 minus 1 will be how much? 1 minus 1 will be 0. So therefore you'll be having 1 by s Laplace transform of t power of 0. So anything to the power of 0 will be 1. So t power of 0 will be 1. The next value that you have is Laplace transform of t power of n minus of 1 over here. I'll replace that value by n minus 1 times of s. So we'll be having n minus 1 times of s into, you have further Laplace transform of t power of n minus of 2. So here you have Laplace transform of t power of n minus of 2 will be n minus 2 by s. So we'll be getting n minus of 2 by s into, you have Laplace transform of t power of n minus of 3. So the process continues, alright, till you reach Laplace transform of t square, and here you can see that Laplace transform of t square is 2 by s into Laplace transform of t power of 1, but Laplace transform of t power of 1 is nothing but 1 by s into Laplace transform of 1. So if you just try to club up these values, you are having n into n minus 1, n minus of 2 and so on. So this n over here into n minus 1 into n minus 2 into 2 into 1. So this gives rise to your n factorial. So it is n factorial whole divided by how many times s is there in the denominator. It starts with n over here and ends with 1. So which means that s is occurring n times. So we'll be getting s power of n. So n factorial divided by s power of n into, you have Laplace transform of 1. But we know the value of Laplace transform of the constant to be equals to 1 by s. So n factorial divided by s power of n, because we know Laplace transform of the constant a is nothing but a by s. So therefore Laplace transform of 1 will be equals to 1 by s, because the value of a is 1 over here. Or further, if I try to rewrite this one, it is n factorial divided by s power of n into s will be s power of n plus 1. So therefore we have Laplace transform of t power of n will be equals to n factorial divided by s power of n plus 1. So this is the particular result when the value of n is a positive integer. When n is a positive integer, we have got this particular result. So we have seen two different results. When n is a constant, then we have got the value of t power of n to be equals to gamma of n plus 1 divided by s power of n plus 1. And here, when the value of n is a positive integer, we have got a t power of n to be equals to n factorial divided by s power of n plus 1. So today we have studied two results, very important results we have studied. The first result that we have studied is Laplace transform of t power of n. Its value is nothing but gamma of n plus 1 divided by s power of n plus 1. Here n is a constant value. If n is a constant, in that case we can use this particular result. Or one more result that we have studied just now, it is t power of n. Its value will be equals to n factorial divided by s power of n plus 1. Here, when the value of n is a positive integer, if n is a positive integer, then you have to use this particular result. So based on the values of n, you have to use for Laplace transform t power of n either the first result or the second result. So that's all I have for today. Thank you.